So, people on the recording, unfortunately, you didn't get to do the activity that we just did, but everything that we talked about, I'm going to explain in these notes here. So, section 5.4, we're going to talk more about relationships, specifically between angles of a triangle and sides of a triangle. Okay? So, looking at, this is not in your notes yet, you can just follow along, but this triangle here, what is my longest side? 13. What is that side called? Yes, I agree, but if I could name it, I would name it BC, right? Okay, so BC is my longest side. What's my next longest side? Which is AB. What's my smallest side? AC. Okay, I agree. Can we see which angles are the largest and the smallest?
Yes.
Without knowing what the angles are?
Yes.
Why?
Because the biggest one is opposite the biggest side.
Correct. So, Audrey, make your angle. Okay, pretend me and Audrey have sides that connect our fingers there. Okay, make your angle bigger than mine. What do you notice about her side length?
It's obtuse.
Her side length.
They're the same.
Hold it up a little bit higher. What do you notice about her side length?
I think it's longer.
It's bigger than mine, right? Switch. Now what do you notice? It got smaller than mine, right? So the angle, the measure of the angle, thank you. Measure of the angle is based off of how big or small the side is. So if my longest side is BC, what is my biggest angle? You can tell me by letter. My biggest angle is A because it's across from that, okay? What is the next biggest angle? C because it's across from the next biggest side. And then our smallest angle is B. Okay, let's kind of do the opposite here. What's my smallest side on this triangle? There's two of them, right? So it doesn't really matter because they're the same. So how can I name one of them? RP and PQ. Yep. What's my biggest side then? RQ. So if I asked you this, what is my biggest angle? Why is my biggest angle P? It's across from the biggest side length. Okay, do I have the smallest angle?
No.
Why not?
Yes.
I do, right? But do you agree two of them are going to be equal?
Yeah.
Okay, so my two smallest angles are Q and R. Okay, so here's what I want you to write off to the side of example 1. Okay, so you can say the smallest angle is across from the smallest side. Do you agree the relationship is the same with the largest angle and the smallest angle? Or sorry, the largest angle and the largest side. Do you agree with that? That is the same. So you can say similar for largest angle and largest side. Okay, so angles and sides relate to each other by being opposite of each other across from the triangle. Okay? So on example 1, it says, which angle measure appears to be the smallest in this triangle? What do you think?
N.
Clap once if you agree with N. Why is it N?
Across.
It's across from that smallest side. Good. What would my biggest angle be in this one? It would be M because it's across from the biggest side. Yes, awesome. On your example 2, which angle is the largest? Clap once if you agree with E. Because why? It's across from the largest side. What's the smallest angle? D. Clap once if you agree with D. Because it's across from the smallest side. Okay. Okay. On example 4, do we have enough information to know what's the biggest side and the smallest side? We don't yet, but do we have enough information to figure it out? Okay, so what do we need to know first? We need to find this missing angle measure. How do we find that? Yep, we know two angles. We can find the third. 65 plus 58, what does that give us? 123. From there, what do I do with 123? 180 minus 123 is 57. So we know that angle is 57. What is the longest side then? Why is it OP? Cross from the largest angle. Good. What about the smallest side? NP again because cross from the smallest side. So I want to look at this set here. Okay, this is kind of like the activity that you guys did with the triangle pieces there. So it gives us 3 side lengths. It wants us to know or figure out if I put those together, will they make a triangle? Okay, so Keaton, what did you say at the beginning that has to be true?
That the 2 first sides have to be greater than the longest side.
Correct. So the 2 smaller sides have to be greater than the longest side. So our 2 smallest sides are 18 and 19, right? So I need to take 18 plus 19, which is 37. 37 has to be greater than what?
40.
Has to be greater than 40. But is that true? No. So will these 3 make a triangle? No. Okay. Similar example as to here. How do I figure out if these 3 sides will make a triangle? Add the shortest ones, right? So we take 33 plus 37, which is 70. What does 70 have to be greater than? 66. The biggest side, 66. Is that true? Yes. So those 3 sides will make a triangle. Okay. So a note I want you to write off to the side of example 5 is the 2 smallest sides must, or say added together, must be greater than the biggest side. Okay, as you're writing that, let's think about this. If on this last example that I had up here, if I had 66 when I added those together, would that make a triangle?
No.
Why not? Has to be greater than. Okay, so it does not matter if these are equal. Okay, this always will have to be greater than. Okay, so maybe underline the word greater than in your definition there. Okay, they must be greater than that biggest side. Okay. Now we're going to talk about what's called a triangle inequality theorem. Okay, so looking at this diagram here, this triangle has a missing side length. Now, do you agree that missing side length can be multiple different lengths?
Yes.
It could be, right? Okay, so we want to figure out the range of what that length could be or needs to be. Okay, so thinking about this, what has to be true?
11 and 16 are greater than x.
Right, these 2 sides here have to, if they added together, they had to be greater than x, correct?
Yeah.
Okay, so I know that 11 plus 16 must be greater than x. Well, can I add 11 and 16 together? I get 27, right? So 27 greater than x. So we know x has to be less than 27. Okay, what else has to be true? Ronan,
It has to be greater than 5
how do you get that?
because
Or how do you know that?
16 would be the biggest side if it's smaller than 16, so it can't go less than 16.
Correct. Another true fact we have to know is that this side plus this side have to be greater than 16. Okay, if we had that scenario there. So we know 11 plus x must be greater than 16. Well, can I solve for x in this case? How? I can subtract 11. So here I get x is greater than 5. So we have 2 scenarios here. Have you guys heard of compound inequalities before?
Yes.
Okay, what a compound inequality is you have 2 inequalities. We want to make one out of that in one true statement. So what we have, comparing our x value, what was the smallest scenario we could have? 5, right? So 5 is our smallest, so x has to be greater than 5. What is our biggest scenario that we could have? 27, and we know x has to be less than 27. So this here is the range of what that value could be. So let me ask you this, looking at that range, what is the smallest side length I could have for that missing side?
5.9999999.
Okay, let's stick to whole numbers.
6.
Has to be 6. Why can it not be 5?
Because it has to be greater than 5.
Has to be greater than 5. It's not equal to 5. Has to be greater than 5. What's my biggest side that it could be?
26.
26. Why can it not be 27?
Less than 2.
It's got to stay less than. It can't be equal to. Okay, so when you're trying to find your triangle inequalities, go ahead and write this off to the side of example 5. Write triangle inequality. Okay, when you're dealing with a triangle inequality, you have two scenarios. Have two scenarios to make a compound inequality. All right, on A, it says, could a triangle have side lengths of 16, 39, and 28? How do I figure out if that's true or not?
16 and 28, add them
Why do you pick those?
because they're the smallest.
Yep, take your two smallest sides, 16 plus 28. What do I get when I add those together? 44. So what does 44 have to be?
Bigger than 39.
Has to be greater than 39. Is that true? Yes. So those three sides can make a triangle. Awesome. On part B, it says a triangle has side lengths that are 30 and 50 inches. What are the possible lengths of the third side? How do we figure this out? What is our answer going to look like? It's going to be a compound inequality, right? So if it helps, you can draw yourself a picture here. Okay, if we have 30 and 50, we want to figure out what this missing side could be. Okay, so what's one scenario that must be true?
There has to be greater than.
Go for it.
What?
Go for it.
Oh, has to be greater than 20.
Right, because you found out that these two must be greater than what when they're added together? They must be greater than 50. So if I take 30 plus x, that has to be greater than 50. How do I solve? Subtract 30. So we get x has to be greater than 20. That's one scenario. How do I get my other scenario?
30 plus 50 has to be greater than x.
Correct. Yep. These two sides here must be greater than x if that were to be true. So we take 30 plus 50 to be greater than x. What's 30 plus 50? So we know 80 must be greater than x. How do I write these two scenarios as a compound inequality?
20 has to be less than x, and x has to be less than 80.
Correct. Yep. When you write your compound inequalities, your smallest number will always be on the left. Your biggest number will always be on the right. Okay. And x is always going to be in the middle. Okay. Are these signs always going to be this direction in a compound inequality?
No.
Yes.
They will be in a compound inequality, yes. If then they would just be like turned around. Does that make sense? But you always want to write compound inequalities from smallest to biggest. Okay, because you always read from least to greatest. If we were to put that on a number line, you would want to read it from least to greatest. Okay. Okay, number 1 says how are side lengths and angle measures in a triangle related? How do we relate them?
The largest.
Yeah, Aaron, you're right. They're opposite from each other, right? So, for example, the smallest angle is opposite from the smallest side, and vice versa for the largest, okay? Number 2 says, if a triangle has 3 different side lengths, what does that tell you about the measures of the angles?
They're all different.
They're all going to be different, right? Because depending on what the side is, that tells you how big or small the angle is. Good. Number 3, Richard says that angle X must be the largest angle. Explain his error.
Not
We don't
across
know the
from
length of
longest side.
x.
Correct. We don't really know the length of XZ, but looking at XZ, it looks like it's the largest side, right? So what would be the biggest angle if XZ is our biggest side?
Angle y.
Angle Y, yes. Number 4, an isosceles triangle. What's that?
Two sides equals.
Yeah, 2 equal angles and 2 equal sides. Good. Has base angles that each measure 50. How could you determine whether B or S is greater?
Because it's an isosceles triangle.
Figure out that.
You
So one
would
side is
know.
bigger than the other two.
You can figure out the third angle, right? What would our third angle be in this scenario? It would be 80, right? So which side, S or B, is bigger? B would have to be the largest side. Okay, and then number 5, it says in the triangle, side lengths A is less than C, which is less than B. It wants us to list the angles in order from smallest to largest. What is my smallest angle?
A.
It is A, the angle A there, because it's across from the smallest side. So A, what's the next?
C.
It is C, what's next?
B.
B. Okay, kind of just worked out that they were the same letters there. That will not always be the case. Okay.